All right, before we talk about polar equations, I realized that example 7 and 8 didn't make it into the previous video. So in the previous video, we talked about taking a polar coordinate and switching it to a rectangular coordinate. But what we want to do now is go the opposite direction. I have a rectangular coordinate, so we've been given an X and a Y, and we want to find the corresponding polar coordinate. So we have to first figure out r. Since x squared plus y squared is equal to r squared, then that means r is equal to the square root of x squared plus y squared. We only need the positive square root because it represents a distance. And then we're always going to use the relationship that tangent of theta is equal to y over x, because that helps us introduce both the x and the y into the scenario. So we're going to start by figuring out r. So r is going to be equal to the square root of -1 squared plus the square root of 3 squared, which comes out to the square root of 4, which is equal to 2. So there's our radius. Now, to figure out theta, we know that the tangent of theta is equal to the square root of 3 over -1. Well, on the unit circle, there's two places where the tangent of theta is equal to -3 or negative square root of 3. So tangent is negative in both quadrants 2 and 4. So the two possibilities for theta are going to be 2 pi thirds and 5 pi thirds. However, we can determine the quadrant we want based on the ordered pair that we have. The ordered pair that we have has a negative x and a positive y. So this would be quadrant 2. So that tells us that 2 pi thirds is the value we want for theta. So the ordered pair is going to be 2 pi thirds. That's our r comma theta. That's our polar coordinate. So go ahead and pause for a moment and try number 8, and I'll come back with the answer in just a couple of seconds. All right, go ahead and check your work there. And we're going to go ahead and move on then to polar equations. So we're real used to working with rectangular functions. That would be something of the form f of x equals 2x plus 3, or y equals x squared. These are going to be in terms of x and y. A polar equation, since we have r and theta, are going to be in terms of r and theta. So here's two examples of polar equations, okay? And these are both r written in terms of theta. So r has been solved for to get by itself. So to convert a rectangular equation to polar, this is the easier way to go. We want to replace our x's with r cosine theta and our y's with r sine theta. So to start on this first one, x is equal to r cosine theta plus y, whoops, not y, we're replacing y. Y is equal to r sine theta, and that is equal to 5. Now, this one does tell us to express r in terms of theta, which means we need to solve for r. So to do that, we can factor the common r out. We get cosine theta plus sine theta. That's all equal to 5. Then we can divide both sides. So we get that r is equal to 5 over cosine theta plus sine theta. So that was actually the example equation that was given above. That is where that comes from. So we know that x plus y equals 5 is the graph of a line in rectangular. So to achieve that same line in polar, this is the equation that we would need to graph for various values of theta. All right, let's look at number 10. For number 10, I might suggest that we expand this out first. So if we square x minus 1, we get x squared minus 2x plus 1 plus y squared equals 1. The y or the ones are going to zero out. So we have x squared minus 2x plus y squared equals 0. Now we can go ahead and make our substitutions. So x is equal to r cosine theta. If I square that, we have to square both the r and the cosine of theta. So r squared cosine squared theta minus 2r cosine theta plus y is equal to r sine theta. So this will be r squared sine squared theta equals 0. Now, again, we need to express r in terms of theta, which means we need to solve for r. This one is quite a bit trickier. But the first thing I notice, if we go back to our trig identities, is that I see that I've got a cosine squared and a sine squared. And I know that sine squared plus cosine squared is equal to 1. So I'm going to go ahead and regroup this to group this term and this term together and factor out the common r squared. So now I have r squared times cosine squared theta plus sine squared theta minus 2r cosine theta equals 0. This is all equal to 1, cosine squared plus sine squared. So this just becomes r squared times 1 is equal to 2r cosine theta, and that is equal to 0. Now, it's a little unclear where to go from here, but remember, our goal is to solve for r. So let's factor and see where that is going to take us. I can factor out an r, and that gives me r minus 2 cosine theta equals 0, which means that either, based on the zero product property, r is equal to 0 or r is equal to 2 cosine theta. Now, this could mean that there's two different polar equations that graph this exact same function. However, if we consider both of these, the question is there a value of theta so that 2 cosine theta would also be equal to 0? And there definitely is, okay? There's several. If theta was equal to pi halves, that would be 2 times 0, so we'd get r equals 0. So we only need this one equation because r equals 0 is a solution that is included in this equation. If we simply chose r equals 0, that's just a dot. That's just the pole of the polar function. And so we would not be including all the possible solutions that we are when we say r equals 2 cosine theta, which is going to be the graph of a circle. Okay, now going from rectangular to polar is fairly simple comparatively. Going from polar to rectangular is a little bit more of a puzzle. And so in order to convert in that direction, we want to use one of these 4 relationships. Now, these are not typically going to be as obvious with what we start with. And so to use these equations, you often are going to have to do some algebraic manipulation to the polar equation, such as squaring both sides, using an identity, and so on, to be able to obtain one of those 4 forms where we can then make a substitution. For example, on number 11, I would start by squaring both sides because that gets me the fact that r squared is equal to 25. And then what do we know about r squared? R squared is equal to x squared plus y squared. That equals 25. The graph of r equals 5 is going to be a circle with a radius of 5, which makes sense. And so this is our rectangular equation. For number 12, I have the value of theta. Okay, so I need to get this in terms of x and y. So the easiest way to do that is to take the tangent of both sides. Tangent of theta equals the tangent of 3 pi fourths. Okay, so the equation that we get is that tangent of theta is equal to -1. And now I know that the tangent of theta is equal to y over x. So y over x equals -1. That would be a perfectly fine way to leave your answer, but it's also convenient to go ahead and multiply by x on both sides and get this into function form, y equals -x. All right, I'm going to suggest that you pause the video here and go ahead and try 13 and 14. Before you do, let me give you a couple of hints. On number 13, we need to use an identity to rewrite secant of theta. I would set your goal to have either sines or cosines rather than secant. And then on number 14, your instinct might be to square both sides, but that gets us a sine squared theta, which is not as easy to make substitutions for. Instead, we can also achieve the r squared by multiplying by r on both sides. That would be my suggestion for number 14. Pause the video and come on back to me in just a couple of seconds. All right, so for number 13, hopefully you got that to x equals -2. When we rewrite this in terms of cosine, then we can multiply by cosine on both sides, which gets us the r cosine theta. Now on number 14, if you get to x squared plus y squared equals 10y, and again, multiplying by r on both sides gets us the squared on the left and the r sine theta on the right, which is what we needed more than the sine squared. When you get to here, this is a just fine answer, but if it's asking you to identify what this function would look like, it may not be as obvious in this form. So I want to go ahead and keep manipulating this so we can see what this is going to come out to. So if we subtract the 10y from both sides, we get x squared plus y squared minus 10y equals 0. Then on y squared minus 10y, we can complete the square by adding 25 to both sides. When we do that, if we just focus on the y part, we have x squared plus, this now factors to y minus 5 squared equals 25. And in this form, you can see that this is a circle with a center at 0, 5 and a radius of 5. Okay, so you're going to be practicing converting rectangular and polar coordinates to their corresponding polar or rectangular, as well as polar and rectangular equations in either direction. So that was a quick little introduction review from pre-calc, and we'll start talking about this in terms of the calculus over the next couple of days.